to this computer and we're going to get started. So Shelby, if you want to open up the slideshow, that'd be pretty sick. We're going to jump into our first activity. So if you're looking at this, if you're looking for this in your textbook, if you want to do it in your textbook, it's lesson 10, activity 4. Okay. If you want to do it in your textbook, I know that most of you guys didn't bring your textbooks home, and that's okay. Okay. So it's activity 4 if you want to be in that textbook. So we're looking at this graph. This graph shows the speed of a car as a function of time. So speed as a function of time. So which of these is going to go on my x-axis? Which one? When we're talking about a function sentence, what is a function of what? We always talk about it as what is a function of what? Output as a function of input, or input is a function of output? How do we usually write it? Very good. We always write it, very good, Tiffany and Matthias. We always write it as output is a function of input. Very nice job, both of you guys. Output is a function of input. Okay? And when we talk about function, output is a function of input. Output talks about our y values or our y-axis, and input talks about our x-axis. So our speed should be on our y, which is correct. Our time should be on our x. Very good. So, did the car speed up faster or did it slow down faster? So first thing I want to ask you, which one of these legs or parts of this graph is speeding up? Is it 1, 2, or 3? Which one of these parts or segments shows where the car is speeding up, getting faster? Rashem, Tiffany, nice job. Rashem, why do you say segment number 1?
Because it's increasing on the graph.
Very good, because it's increasing. The speed is going up. Very good. So this is speeding up. So you don't need to necessarily write this on your slides because I didn't give you like a text box. I just want to label things on my end so that we know speeding up. Which segment here is where it's slowing down? Nice job, Melissa, on that too, by the way. Very good, Rashem. So which one of these, number 1, number 2, or number 3, is where it's slowing down? Which leg here? Let's see in the chat, people. Oh, nice job, Tiffany. Tiffany, do you mind telling me, how did you know that segment number 3 is where it's slowing down?
Because it's decreasing.
Very good, Tiffany. So she said this segment number 3 is where it's slowing down because it's decreasing. Our line is going down. Nice job, Tiffany. So if we're looking at and we're thinking about speed and time, what's happening on segment or leg number 2? What's happening to the speed?
It's consistent.
It's consistent. It's staying the same. Yes, Rashem. Ooh, Rashem is a force to be reckoned with today. So the speed is staying the same. And I'm going to say speed. Okay, so my next question. So that was good. I like that. Did the car speed up faster or did it slow down faster? So which one of these segments, the speeding up or the slowing down, did it do faster? And how did you know? So let's think. Let me know in the chat. What do you think? Did it speed up faster or slow down faster? Let's see what people are thinking. Tiffany said it's speeding up faster. What else are people thinking? Is it speeding up faster? Or is it slowing down faster? What do we think? Let's get some answers in the chat. What are we thinking? Very good, Edgar. Edgar, why do you think that it's speeding up faster?
Because the line is steeper than when it's slowing down.
Very good, Edgar. He said it's speeding up. Because our line is steeper. Awesome job there. That's such a good point to make there. That's exactly the reason why we're thinking that. So it's speeding up faster because the line is steeper. And steeper is S-T-E-E-P-E-R. Very good. Let's get that written down if we didn't know that. So if you look at it, it's going up faster, it's steeper, it's closer to being straight, up and down. So when we're talking about steepness, it's how diagonal it is, right? So if it's closer to being up and down, it's steeper, right? It's going faster. Nice job. Very good, Edgar, on that explanation there. Really good. Now, how did we know that the car stayed at that speed for a period of time? So on segment number 2, how did we know that the speed stayed the same? How did we know that it stayed the same? Because that's what Rashem asked me, or that's what Rashem told me when I asked him what's happening on number 2. He said it's staying the same. How do we know that it's staying the same? What do we think? Nice job. Tiffany said because it's a straight, and then I'm gonna add a word to it. It's a straight horizontal line or side to side. So when we have a straight horizontal line, that means that it's staying the same. It's not changing. It's staying the same, not changing. Very good. Nice job there, Tiffany. I thought I was going to trick you, but I didn't. So let's make sure that we have both of these reasons or pieces written down, either in our slides or in your textbook for that there. Okay. Awesome job. So we know that it's staying the same if we have a horizontal side-to-side line. Nice job, my friends. I'm going to give another 10 seconds for us to write this down. Make sure we have it written down on our slides. And then we're going to scooch down to slide number 2. Let me grab my eraser. So for slide number 2, if you're in your textbook, I'll write it on the top of the slide. You're on lesson 10, cool down. Okay, let me erase my board. Okay, so the next one is the next slide here. It is lesson 10, cool down. Okay, if you're looking in your textbook, that's where it's gonna be. So it's if you flip like 2 pages forward. Or yeah, like forward. So like keep going. Okay, so we have this graph. The only thing is that if you look at it in the textbook, it looks a little bit different because I added these lines on it to make it a little bit easier for us to read, okay? So if the graph in the book means the same thing as the graph here, I just put these little blue lines on so that we could easily find our data values, okay? So let's look at number 1 here. It says, Lynn uses an app to graph the charge on her phone. When did Lynn start using her phone? According to this graph, when did she start using her phone? So when it was at 100%, okay, but what time? You're gonna have to look, which axis here is talking about time, our X or our Y? Very good, Tiffany. So we're looking for the time that she started using her phone. So if we look at this guy here and we say, when did she start using her phone? When did her battery start going down? What time did she start using her phone? When X was equal to what? When X was equal to what? When did she start using her phone? Very good, Tiffany. Maybe 1 o'clock, very good, 2 o'clock. So when we're talking about Lynn's phone charge here, we're looking for when it started to go down. So if we look at when it started to go down, it started to go down at what time? So when did it start going down? If we look at our graph, it started going down right here. What time is that? It's at 2 o'clock. So when did she start using her phone? At 2 o'clock, because that's when the charge started going down. It was at 100% from 12 o'clock to 2 o'clock because she didn't use it. I mean, in theory, it would still go down, but from 12 o'clock to 2 o'clock, she didn't use it, so the charge didn't go down. It started going down at 2 o'clock because she started to use it. And then when did she start charging her phone? So when did it start going back up? Very good, Tiffany. Very good, Melissa. So when did she start charging her phone? When did it start going back up? What time did she start charging her phone, guys? Nice job, Rashem. Very good job, Melissa, Mateo, Tiffany, Rashem. Very good. So when did it start going back up? When did she start charging it again? At 8 o'clock. Very good. To all my friends that put answers in the chat, high five. Thank you for that active participation. I love it. So while she was using her phone, at what rate did her phone battery die? Okay. So that means we need to find our rate of change. So we're going to have to draw in a what? A slope. What? Slope triangle. Yes, Tiffany, very good. So we're going to have to draw in a slope triangle here where it's she's using her phone. The rate at which it's dying is from this point here, from 2 o'clock to 4 o'clock. So what's my rise going to be? How much did our phone battery go down? It went from 100 to what? How much percent did she go all the way down to? Very good, Melissa. She went down to 40%. So how much percent of her battery did she use? If she went from 0 to 40%, what percent of her battery did she end up using? Very good, Melissa. Very good, Tiffany. What percent of her battery did she end up using? Very good, Tiffany. She went from 100 to 40. How much did she take away there, guys? Very good, Tiffany and Melissa. I just want to see if a couple other people want to put their answers in the chat. So if we go from 100 to 40, it's going to be a change of 60. But what kind of 60 is it going to be? It's going down, right? So our rate of change is going to be what? Very good, Matthias. It's going to be very good, Tiffany. It's going to be a negative number. Very good. So it's going to be negative 60. Oh, sorry. Did someone just shout out? No? Very good. So it's going to be a negative 60. That's our rise is negative 60 over what's our run? What's our run here? How much time has gone by? What's the change in our time? Very good, Tiffany. It's a run of, very good, Tiffany. A run of 1, 2. So it is a run of 2 because it goes from 2 o'clock to 4 o'clock. So my rate of change, if I write it as rise over run, what's my rate of change going to be? What over what? Rise over run. Very good, Melissa. Very good, Matthias. Negative 60 over 2, which if you grab your calculator, that calculates out to negative what? Grab your calculator, calculate it. 60 divided by 2 gets me negative, not 40, 30. Yes, Risham. 5's it up, dude. Negative 30. Very good. Nice job. So every hour, how much percent of her battery dies or goes away? Very good, Melissa. So every hour she loses 30% of her battery. Very good, Risham. 30% of her battery. Very nice. Okay. Last little piece on this slide here. This is sort of like extra, but I want to talk about it. So if we look at segment piece number 1, what's happening with piece number 1? Her battery is staying the same. So do we think that she's using her phone during that time or no? No, she's very good. She's not using her phone. You don't need to write this down. I just sort of want to talk about this graph because I think this graph is a little bit hard for some of us to sort of grasp and understand. So she's not using it in part number 1. So now if we look at segment number 2, what is she doing in segment number 2? If we're talking about phone usage, what's happening in that second little piece of this graph here? From 2 o'clock to 4 o'clock. What's she doing with her phone? It's going down. Her battery charge is going down. So what must she be doing? It's going down because she's using it. Very good, Tiffany and Melissa. So in segment number 2, she's using her phone. If we now look at segment number 3, what's happening to her charge there? First off, what's happening to her charge? This little flat piece right over here. That's okay. She's not using it. Good. It's staying the same. Charge is staying the same. So she must not be, very good there. Good catch there, Tiffany. So she must not be using it. Very nice job, Melissa. So she's not using phone. Very good. Nice job. I thought I was going to be able to trick you on that one. Now, let's look at, I think Tiffany's got this one. Let's look at segment number 4. What's happening on segment number 4 of our graph. What is she doing with her phone? Very good. She's charging her phone. Maybe she's using it, Rashem, but we know for a fact that the charge is going up, so she must be charging it, right? Could be using it. I'm gonna put that down because we don't know for sure, Rashem. Could be using it. I know that I use my phone when I charge it and it still charges, so that's a fair assumption to say there, Rashem. Very good, my friend. Now, let's look at this last segment here. If you look at segment number 5, what do we notice about this piece right here? Very good, Melissa. And how do you know that she's not using it? It's fully charged again, good. And we can also say that she's not using it. Why can we say that she's not using it? Because it's staying the same. Very good. Because it's staying the same. The charge is staying the same. If she was using it, it would be what? Yes, Tiffany. If she was using it, it would be going down. So listen, I understand that I just took a bunch of time to sort of go through this graph, but I think that this graph for some people was a little bit confusing. So I wanted to go through it and talk about what each piece of this graph actually meant, because I think that was important because we might see this graph again moving forward. Okay, so I am going to take my eraser now and I'm going to erase, and we're going to look at your. Oh, there he is. Perfect. And we're going to take a look at the next piece of this, okay? Okay, so we have slide number 3. If you're in your textbook, this is all the way back in lesson number 5. Okay, so it's all the way back in lesson number 5, and it's the cool down. Okay, so if you're looking in your textbook for where this lives, it's on lesson number 5, the cool down. Okay, so let's take a look at Diego. And Diego is running a 10-kilometer race and keeps track of his speed. So our distance is down on the bottom, and our time is on our x-axis. So which one of these is our input? Is our distance the input or our speed the input? Nice job, Shelby. Why do you say speed so Shelby's saying speed is our input. Input lives on which axis? Think back, we've talked about this. Input, when we talk about the input of a function, which axis, X or Y, does our input live? Our input lives on our x-axis. So our input in this story is our distance. Okay? So our input in this story is our distance because it lives on our x-axis here. Very nice job, Shelby, Matthias, and Melissa. Boom, nailed it. So we're looking at this graph now. What was Diego's speed at the 5-kilometer mark of the race? So what was his speed at the 5-kilometer mark of this race? So where am I going to look for the 5? Am I going to look for 5 on the x-axis or the y-axis? Very good, Melissa. Very good, Melissa. Very good. Just running it like it's your no business, nobody's business there. Nice job. So we're looking for the 5-kilometer mark that means we're gonna be looking for the 5 on the x-axis. And they're labeled every other, so we know that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So I'm looking for the 5-kilometer mark. Where does my line hit? At what speed is he going at the 5-kilometer mark? No, you were right with your first number, Melissa. How fast is he going at the 5-kilometer mark? The kilometers are on the bottom, on the x-axis. You're looking for 5 on the x-axis. What is his speed? What is his output when his input is 10? It's not going to be 11, because at 5, we come up and we bring it over. And where does it hit our y-axis? It hits at 10 miles per hour, kilometers per hour. So 10 kilometers per hour. Okay. Do you see that? Oh yeah, not a big deal, Tiffany. You're doing great today. I'm so proud of you. Keep it up. Does everyone see how we found that one there? This graph is a little bit tricky because usually when we talk about distance is usually on our y-axis, but today distance is on our x. It was a little bit of a trickster. So we want to pay really close attention to our axes when we're answering questions like this, okay? So according to the graph, where was Diego when his speed was the slowest? So we're going to look for which axis has the lowest number. When he's talking about his speed is the lowest. How far was he in the rate? Very good, Melissa. So we're going to look on the y-axis where our y is the lowest. So what is his distance when he hits his lowest speed? So we're looking for the lowest speed, and that would be where the lowest speed where it hits the y-axis at the lowest point. How far was he in his race at that point? Very good, Tiffany. Very good, Matthias. Very good, Melissa. How far was he in his race when he hit his lowest speed? When the speed was at the lowest peak here, how long, what was his distance? Very good, Melissa.
3 kilometers.
Well, 3 kilometers. Yes, Joe. Very good. So according to the graph, where is he going the slowest? At 3 kilometers. Very good, Joe. Very good, Melissa. Very good, Matthias and Tiffany. So at 3 kilometers. Okay. Okay, so my last question here. It says, describe what happened to Diego's speed in the second half of the race. So from 5 kilometers all the way up to 10 kilometers. So what happens to his speed first? From 5 to 6 kilometers, what happens to his speed? Very good, Tiffany. From 5 to 6 kilometers, he's speeding up. Because his line is going up. Then from 6 to 8, what's happening from 6 to 8 here? What's happening to his speed? Very good, Tiffany. Very good, Rashem. He slowed down. His speed is decreasing. Yes, that's such a good word to use there, Rashem. It's going down. Very good, Melissa. His speed. Oh, that's bad. Decrease. And I love that word that Rashem used. That's such a very mathematical word. I like it. You could also say his speed went down. That means the same thing. You could also say he slowed down. Then from 8 to 9 kilometers, what happened? He got a little bit faster. Very good. He sped up again. And then lastly, from 9 to 10, what happened to him? He stayed the same. Very good. Very good. Awesome job, everybody. I am so proud of every single person in here today. I had so much active participation. I am so proud of you. Awesome, awesome job. Very good. So your homework for this evening, here is the dealio. The CFA on the next slide is a little bit difficult. I understand that. I want you to just go in and get it done. It's okay. The scores are not going in the book. I want you to try your best. Give it your best shot. Reach out to me if you have any questions. Please jump in and do that for your homework this evening. I'm going to leave this up in case you need to get this written down. If you have this all written down, you can jump into science and I will see you guys tomorrow. Please make sure that you come to class tomorrow. Thank you so much, guys. I'll see you later. Please complete the CFA. Please complete the CFA. Remember, it's how they judge me as a teacher is if you get it done. So please get it done. Try your best. Let me know if you have any questions. You can write this down. You can stay in another minute to get this written down. Everybody else, if you finish writing it down, you can head out to science. I will see everybody from period 2 later. I'm so glad that you all made it to class. My friends from period 3, if you wouldn't mind, please open up the slideshow for today. I am going to stop sharing this in a moment. I just am leaving it up because a couple people are still in copying down.
Chad, we have a person for the elevator. He just came in the back door. He's here to check the elevator.
Courtney is here. Carter, Mario is here. Okay, Sam B, I'm gonna jump you out, Sam B. I will see you tomorrow, okay, buddy? Let's see, is there anybody else that's in here that really shouldn't be in? No, awesome. Aaliyah is here. It's so good to see you guys. Please open up the slideshow for today. And let's take a look at the first slide together. I am going to be going through this in a moment, so please give me one moment to sort of let some more people